Look at that, I'm on time. What kind of questions do you have for me? I'm going to finish covering the right triangle handout that we did. We'll talk about bearings today. Yes, sir. Is that it? Yes, sir.
I had a question.
Okay.
It was the sixth question. It was like it would be like tangent equals square root of 3. It was like the chart basically, but every time I got the answer, it would say there should be more numbers.
Because you have to give two angles in the interval from 0 to 360 that makes that true. Right? So if it's a positive number, tangent is positive in quadrants 1 and 3. So for instance, if we use your square root of 3, so let me put down today's date. Today is 9/9. Is that large enough? Do I need to zoom anybody? Can you see that way back there? Okay, so a web work question was like this, some version of this. If the tangent of angle theta is equal to the square root of 3, find all angles theta in the interval from 0 to 360 that make this true. And so what we have to do is go through the table a little bit backwards and try to figure out which angle in the first quadrant this happens, and then we'll figure out the angle in quadrant 3, because remember, tangent is also positive in quadrant 3. So in order to get tangent to reduce to square root of 3, remember that tangent of any angle is the ratio of the sine of that angle with the cosine of that angle. So in order to end up with a square root of 3 as the result of this division, you're going to need a square root of 3 over 2 on the top and a 1/2 on the bottom, so that the 1/2s will cancel. Now, is that an angle that you would recognize? What angle is the sine equal to the square root of 3 over 2? That'd be a 60-degree angle, wouldn't it? So this says that in quadrant 1, theta is equal to 60 degrees. That's from memorization now. That's not something that I can let slide. You got to get that table memorized. Now we're going to use that 60-degree angle to compute the measure of the angle in quadrant 3. So to get the one in quadrant 3, we start with 180 degrees and we increase that by 60 degrees. So 180 plus 60 will be the quadrant 3 angle. So the next one is theta is equal to 240 degrees. So in one lap around the unit circle, you should get 2 angles that generate positive values and 2 that generate negative values. So that might be what you were missing on that problem. Is that okay? I have a question. Okay. Okay, so we enter the name of the cofunction and then the angle measure. So if the answer is, so we want to find the cofunction of the secant and the angle measure of the secant. Okay, so our cofunction identities, so again from WebWork. So our cofunction identities relate the trig functions with the ones that have the word co at the beginning. So sine and cosine are cofunctions of one another. And that means that if I know the sine of an angle, the sine of any angle, that's the same as the cosine of that angle taken away from 90 degrees. Tangent and cotangent are cofunctions. And then secant and cosecant are cofunctions. So in this web work problem, you are given secant of 32 degrees. And in the first blank, you put the name of the cofunction. And in the second blank, you put the measure of the angle. So you just read up here, the cofunction would be the cosecant. And the measure of the angle is whatever you get when you take 32 away from 90. So for this problem, it will be the cosecant of, what is that, 58 degrees? So there's our answer on that one. Is that okay? What else? Any others?
Number 4, it says like the warning thing, and it's like there may be something wrong with this question, and it's about like reference angles.
But there's nothing wrong with the question other than that warning pops up.
That's it. It's
That's
just
it.
there.
Yeah. Work it anyway. That warning on question 4 is, that's the mistake. The warning doesn't, the problem works out fine.
Okay, but can we try beta is equal to 568, so, and then you have to find the reference angle for that one?
So that's all we need is the reference angle?
Yeah.
So what we first have to do is decide in which quadrant that angle is. So let's see, if I start with the positive x-axis and go all the way around the circle, that's 360 degrees. 2 full laps around the circle is 720. So it's within 2 full laps. So let me kind of draw a picture instead of wiggle my arms around up here. From here to here takes me to 360 degrees. All the way around again takes us to 720, so we need to not go that far. But if I went halfway around, I go 360 plus 180. That's at 540 degrees. So from here, another 180 takes me to 540. And then I have to go just a nudge further to get to the 568. That amount of distance that I'm going further is the reference angle. You always measure the reference angle from the nearest x-axis. So here our nearest x-axis was the one that was the 540 degrees. So in this example, the reference angle is 568 minus 540. So I denote the reference angle as theta prime. So make sure you go to the nearest x-axis. So 568 minus 540 gives me the amount of distance that I've traveled from that x-axis. And so I guess that looks like 28 degrees as our reference angle. So please ignore the warning on that web work on number 4. Where in life, in general, don't ignore warning messages. It's just this web work is pretty harmless. Anything else? Okay, let me take a peek at where I stopped last time. I think I was on the 5th problem. Does that sound right? Okay. We'll do the fifth problem and then we'll take a stop and talk about bearings. Okay, so some of these problems are really dependent on how well you can draw the pictures. Oh, I missed this one. Okay, let's back up and answer the question about the cofunction of t minus 5. Let me back up here. So same web work from here. So you can see that. Yes, we want to find the cofunction of the cosine of t minus 5. So we're going to use this identity, but we're going to switch it over to the other way. That if I have the cosine of an angle, then its cofunction is the sine, and the measure of the angle is still 90 minus theta. So in this example, theta is t minus 5. And so the cofunction is sine, and then the angle is 90 minus the t minus 5. You can enter that just like that, or you can simplify a little bit. If you were to distribute the minus sign, this becomes 90 minus t plus 5. So you can write that as 95 minus t. Okay. So there's that web work problem there. Okay. All right, so now let's go back to that handout. We were looking at our right triangle word problems. So the important thing was to be able to draw the picture. Well, another important thing is to be able to see the question. Close, I'm getting close. And there. Okay, a pilot measures the angles of depression of two ships to be 52 degrees and 40 degrees. If the pilot is flying at an elevation of 35,000 feet, how far apart are the ships? Okay, so let's put a pilot up in the air. And then let's put our two ships here, ship number 1 and ship number 2. You know, the pilot is 35,000 feet above the ground. So we're just looking at that one particular instant. It's not like he stopped right there and hovering. The angle of depression between the two ships, ship 1, there's ship 2. So let's get a line through those. The angle of depression is measured from the horizontal. So to one ship, it's 52 degrees. That's the angle measured from the horizontal. So here's the 52 degrees right here. And then to the other ship, it's 40 degrees. And so let me draw this line here. And this angle is the 40-degree angle. So 52 is the bigger one. 40 degree goes to ship number 2. And how far apart are the ships? So our unknown is this distance right here. And our right triangles are that little one with the 35,000 feet and ship number 1. And so we've got this triangle here is a right triangle. And then we've got the large right triangle. This triangle in here is an obtuse triangle, so we can't use our right triangle trig in there. So the other right triangle is from P all the way out from, let's go, let me call this point O for the origin. So we have triangle P, O, and ship number 1, and we have triangle P, O, and ship number 2. Our plan is to find X, which is not even a length of any of the sides of those two triangles. So I'm going to throw in a few more variables. I'm going to say that this leg has a length of A, and this leg out here has a length of B, where what we know about B is that it's X plus A. Is that okay? So if I were to draw a triangle POS1, it would look like this. The right angle's here. The 35,000 is here. The letter A is here. If the angle up here is 52 degrees, can you tell me, for instance, the angle right here? How much? 38, because those two angles would make a right angle. So I can use this 38-degree angle here and help me write something to find the variable A. A is opposite the 38-degree angle, and the 35,000 is adjacent to the 38-degree angle. So which trig function's talking to you here? Tangent. The tangent of that 38 degrees is equal to A over 35,000. Let's start with that. We have the tangent of 38 degrees is equal to A divided by 35,000. And so if I solve that for A, I'll multiply by 35,000 and get A is 35,000 times the tangent of 38 degrees. Let's put that in a box and we'll come back and get it later. Now let's draw triangle PO ship number 2. That one would look like this, where we've got 35,000 here. This is still the right angle. This side now is length B, that big length. And if this angle up here is 40, what is the measure of this angle in here? That will be 50. So we'll do the exact same thing using those numbers. So our next equation says that the tangent of 50 degrees is B over 35,000. And we'll multiply both sides by 35,000 so that we get B is 35,000 tangent of 50 degrees. Put that in a box. And now our job is to find X. So the third thing we do is use this. B was the sum of X and A, so X is B minus A. So take the stuff that we got in the box here, 35,000 tangent of 50 degrees, and subtract off the stuff we got in the box here. I'm going to go ahead and factor out the 35,000 because I run out of room. And now it fits a little bit better. You can leave it like that for me on a test. For web work, we need the calculator, which I did bring again. Again, make sure your calculator is in the degree mode. So I'm going to enter it just the way I see it here. 35,000. 5 back. Oops, back. Times the tangent of 50 degrees minus the tangent of 38 degrees. And everything was done without any decimal places in your statement of the problem. So I'm going to take my answer just to the nearest whole number. So I get x is equal to 14366, and that's going to be feet apart. Is that okay? We're doing these too fast? All right. The next two problems deal with measurements called bearings. And there are two different ways that bearings can be measured. The first way measures from a north line in a clockwise direction. That's kind of the easiest way to measure bearings. And then the other bearings measures from stated directions. So let's look at bearings before I go to the next problem. So in section, I guess we're in chapter 2 still. In section 2.5, there is still right triangle trigonometry, but it deals with using bearings. So there are two ways they're measured. Sometimes a single angle is given. If a single angle is given, then the angle measurements is, then the angle measurement is from a line pointing due north and the angle is measured in a clockwise direction from that due north line. For example, if you were seeing a bearing of 30 degrees, from point P, then from point P, draw yourself a due north line. Then you get out your compass and you measure a 30-degree angle. So a right angle is 90 degrees, a 30-degree would be about 1/3 that way. We go clockwise, 30 degrees. So it's pointing in something this direction. Where a bearing of (300 degrees looks like this. From point P, our due north line. If I go from point P all the way back to point P, that's 360 degrees. So I measure from point P, not quite all the way back, right? All the way back is 360. So I'm 60 degrees short of being all the way back. So there's the bearing of 300 degrees, where this little measurement here then would be 60 degrees. Always measured clockwise. So pilots would use bearings, ships at sea would use bearings. I don't know, we got any geology people in here that uses the little? Yeah. We use bearings in trig in section 2.5. That's where I use it. So let me work one out of the book first. Page 87. Is that the same as this one? Number 16. Let's see a number 16 on that page. Okay, so I won't do that. I'll just work one on the sheet. It's not that one. Let's just do the one on the sheet. Number 6, a ship travels 55 kilometers on a bearing of 27 degrees and then travels on a bearing of 117 degrees for 40 kilometers. Find the distance between its starting point and its ending point. Okay, so let's see. Let's see if I can draw this. So from a north line, I'm going to draw a bearing of 27 degrees. So I'll just fake it. There's 27 degrees. Ship travels 55 kilometers. So here's 55 kilometers. It takes me to here. From here to here on the bearing of 27 degrees. Now it's going to travel on a bearing of 117 degrees. So from that terminal point, I'm going to draw another north line and measure a 117 degree angle. So from here to here would be a 90 degree angle. From here to here would be 180 degrees. So 117 might be putting me somewhere in the neighborhood of here. The ship now is going to travel there for a while. He goes 140 kilometers. Okay, so at the end of that time, I want to measure the distance to the starting point. So here's the start, here's the finish. I want to measure that distance right there. You understand how I made that picture? So neither of those two angles are measures of any of the angles interior to the triangle. We can do a little work and see if we have a right triangle for one, and then see if we can find the measures of at least one of the interior angles. Our goal is to find this length here. And we know this length is 55 kilometers, and that length is 140 kilometers. So what we probably want to do is see if we can figure out the measure of any of these angles. So let's see, what do we know about parallel lines cut by a transversal? Here's that 27-degree angle. This is my first north line and my second north line. When we have parallel lines cut by a transversal, you're looking over here, we have some congruent angles. That angle is interior to the parallel lines and above the transversal. So its alternate interior angle should still be interior to the parallel lines, but on the opposite side of the transversal. And remember that alternate interior angles are congruent. So can you see the alternate interior angle to the 27-degree angle on this picture? Agree that it's this one here? So alternate interior angles are congruent, that's 27 degrees. In this picture, if I were to extend this down here, where is that? That's right here, correct? So this little piece here is 27 degrees. And then we can figure out the measure of this one. I've got here, let's see. Yeah, this is the 117-degree angle. So this angle here is 180 minus 117. So that's a 63-degree angle. And looky there, what's the sum of 63 and 27? So this angle right here is a 90-degree angle. So let me redraw that triangle now. We've got a 90-degree angle there with that work. We've got 55 kilometers here. We have 140 kilometers there. And we have X here. So now what we have to do is figure out some of these other angles. Or do we? We don't need anything else. We're done. Almost. Given two sides of a right triangle, we are now asked to find the third side. Use the Pythagorean theorem. Leg squared plus leg squared is hypotenuse squared. So leg squared plus leg squared is hypotenuse squared. So our legs are the adjacent sides to the right angle. So we have 55 squared plus 140 squared is c squared. So we'd have to compute that and then take the square root. If you draw your picture right, you should always end up with a right triangle somewhere because we don't know anything about non-right triangles. So let me get this number here. Everything is given in terms of whole numbers, so we want to state our answer as a whole number. So let's see, 55 squared plus 140 squared, and then take the square root of that. I get 150. C is really X, isn't it? Well, I don't know why I used an X. Put a C up here then. So I get C is equal to 150 kilometers. Yeah, you can stop here on a test. Again, I don't want to mess with numbers. Let's see if I have another one similar to that. Okay, so just to keep the same type of example, I made out another example here on another handout, number 1 here. Radar stations A and B are on an east-west line, 3.7 kilometers apart. Station A detects a plane at a point C on a bearing of 53 degrees. Station B detects the same plane at a bearing of 323 degrees. Find the distance of that plane at point C to the station at point B. So what you're going to do is start with a line segment with your two radar stations as the endpoints of that line segment. Draw a north line from station A and measure a bearing of 53 degrees. Draw a north line from point B and measure a bearing of 323 degrees. Draw rays on those bearings and they'll intersect at that point C. Make a big enough picture. There's point A, there's B, everything's measured from a north line. So a bearing of, we know this distance, let me go ahead and put that in. A bearing of 53 degrees. So from a north line here to here is 90 degrees. So 50 is a little bit more than halfway. So let's go a little bit more than halfway. And let's say that that's a 50-degree angle. Just draw a ray and label that angle as 50 degrees. Uh, 53, sorry. Okay, now we're on the bearing from point B and we need to draw an angle of 323 degrees. So that's not quite all the way around back to that north line. All the way around back to that north line is 360. So I'm short of 360 by a bit, by 37 degrees. So go almost all the way around, but stop when you're 37 degrees short of 360. So here, all the way around, oh, maybe to about right there. And then we draw a ray here. So this big circular angle is 323 degrees. And then here's point C right there. And we are supposed to find the distance from B to C. So I'll put the variable right here. You agree with how I've drawn that? So I said these are going to generate right triangles. My suspicion is that the right triangle, the right angle is right there at C. Let's see if we can verify that. We've got the 53-degree angle here. All right. Does that help me in any way? I could tell you what that angle is. What's the measure of this angle? 37, so that they add to 90. Okay. This is not quite all the way around the circle. So I can figure out the measure of that little bitty tiny angle in there. 360 minus 323. What'd you say, 37? So if this little tiny angle is 37, what's this angle right here? We could have used our parallel lines again, right? Notice that those two angles add up to 90 degrees. So that means there's 90 degrees left in our right triangle. So there's our right angle. Okay, these two add to 90. The sum of the angles has to be 180, so that has to be 90. Okay, and so let's see what we know. Let me draw our right triangle again without all that junk on it. There's our right angle. We have 37 degrees here. We have 53 degrees here. We have X here. And we have 3.7 here. So looking at that little triangle that I drew in the margin, so this time we will need a trig function because I don't know anything about that other leg. Then you have your choice of which trig function you need or want to use, because the 3.7 is the hypotenuse. It's the side opposite the right angle. So if you want to use, for instance, the 37-degree angle, which trig function would you use? Sine of the 37-degree angle is opposite over hypotenuse. So I can use that. And then if I multiply both sides by 3.7, I have X. And so let's do that. 3.7 times the sine of 37. Now, since this was given to 1 decimal place accuracy, that's the number of significant digits of your answer. So my answer I'm going to put as 2.2 kilometers. 2.2 kilometers. Anybody playing along with their calculator and agreeing with those numbers? Yes.
On the test,
On the test, you stop right there.
sure that put like more decimal places.
Oh, I don't care about the decimal places. Yeah. But WebWork won't take them. So they're really picky about the significant digits. So when you're doing WebWork and you enter an answer that you know it's right, you probably use too many decimal places. So start knocking some decimal places off until your little square turns green. Okay, another way bearings are measured is by given directions. Again, you start with a north-south line. So let me pull this up and go back to my other page. So another version of bearings uses directions. So we start with a north-south line. And use an acute angle in the stated direction. So for instance, if you have something described as a bearing of north 45 degrees west. So in this particular example, we start with a north line and draw the acute angle in the direction of west of a measure of 45 degrees. So we're starting with the line pointing this way, and then we head toward the west, right? North, east, south, west. So I'm going to go 45 degrees from that north line in the direction of west. If you're asked to draw a bearing of south 30 degrees east, then you begin with a line pointing south. and you draw a 30-degree angle from that line in the direction of east. So I go from here 30 degrees this way. So there's the south, east is pointing here. So 30 degrees from south toward east. So the benefit of this is that we always use acute angles, drawn either from, say, the positive x-axis or the negative x-axis in the direction of either the, positive y-axis or negative y-axis in the direction of either the positive x-axis or the negative x-axis. And so my next example on my original sheet would be example number 6. Let's see if I can find it. Where I put all these things. Nope, example number 6 is not that one. Find it, find it, find it. There it is. There it is, there it is, there it is. We did that one. That's not a bearing. That's a bearing. So that one. That's the one we want. Number 7. I'll do it on this sheet. Nope, I'm gonna do it on that sheet. I just want you to feel this question. See, it works. You're feeling it. A ship leaves at noon. Oh, and heads due west at 20 nautical miles per hour. At 2 p.m., the ship changes, give me an S there, Vanna. The ship changes course to a bearing of north 54 degrees west. Find the ship's bearing and distance from port of departure at 3 p.m. Well, let's see if I know how to draw this. Here is the ship at noon. Heads due west. Oh, I didn't, damn ship, I wanted you to go east. Okay, let's move the ship over so I got room to let him go west. There's my ship at noon. Heads due west at 20 nautical miles per hour. Due west. So here we go. That's 1 hour. That's the other hour. At 20 nautical miles per hour in 2 o'clock, that means it's gone a total of 40 nautical miles, right? 20. Nautical miles are called knots. So there it is at 2 p.m. It's going to change course. So I draw a north line from there. And now 54 degrees in the direction of west. So from there, I'm going 54 degrees. And it's going to travel along this line. And it's going to travel along that line for an hour. I assume it's going the same speed. So let's say that then is 20 knots. Find the ship's bearing and distance from port of departure at 3 p.m. So I want to find this distance. I'm going to miss that dot big time. I'm just going to move 3 p.m. to here. And then I want to find the bearing from here. I'm going to find that bearing, and I want to find that big length. Agree with my picture?
How did you know how to draw the last part?
How did I know how to draw the last part, which was which part? The 54 degrees north, 54 degrees west?
The bearing that you drew.
Well, it said, find the ship's bearing and distance from port of departure at 3 p.m. So I'm going to choose to do the one, we said a bearing has to be an acute angle. So if I drew a south line, it wouldn't be an acute angle to give me that line. It would be obtuse. So I just did the north line. But I don't know where to go from here. I need your help. So that big triangle is certainly not a right triangle, right? That's not a right triangle. Looks like I've got a right angle here because this was going due west and the bearing was measured from north. So I know that's a right angle right there. And my 40 knots is down here. Let me get that out of the way. Okay, what else do I know? Let's see. What else do I know? Where? You know this one? That's 54 degrees. And so we know this angle up here? The whole angle, this whole angle here. Does that help me any?
You can turn the second triangle into a right triangle.
The second triangle into a right triangle. This triangle here you claim is a right triangle?
Yeah, you can just like extend the lines, figure out the.
Okay, I extended the lines.
I mean, like make the right triangle with how far north and west it went. So that's the second one.
I don't know where you're talking.
So with the 20 knots, use the sign or cosine or something.
Well, I don't know that that's a right triangle.
Yeah, you can make one.
How am I making it?
Just make up lines.
Just make up lines.
Can't you put a line from like the point in the middle straight down?
Like
not
that?
No, not that one, but the,
Yeah, you can wait.
like, that first parallel lines, like the 2 o'clock one, the top line. In the 54-degree triangle, and you do like a straight line down.
Down to here, but then I don't know the lengths. It doesn't necessarily bisect that.
But you could find the top angle.
Before I start making right triangles, I want to see what I know about what I got drawn so far. How about that? Well, I probably need a bigger picture. I know I do. I've got my 3 o'clock. I got my 2 o'clock. I got my noon. This angle and that one. Let's see, I got a right angle here. I got a 54-degree angle here. Well, these are parallel lines, but I don't have a transversal anywhere. Need to push that up a bit so I can draw a big enough triangle. There. That was 40. That was 20. And that's 54. That's all we know, huh?
Actually, that would work Plus 90.
Okay, so I do know this whole angle. What does that tell me?
Tells you both your angles for that big triangle.
But that doesn't help because that big triangle is not a right triangle. So far that doesn't help me any. Yes, sir.
The line is 20 now, so
Uh-huh.
why not extend that and make that a transversal?
Extend that and make that a transversal, but then. That help? Yes, keep thinking.
So technically, the knots isn't it like an actual distance, miles per hour, you find the distance like with the knots and then.
Can I find the distance with the, but I don't have a right triangle. I'm going to keep my distance in knots. Knots is a nautical. I want you to look at this triangle here. And see what we know about this triangle. Yes, go ahead.
So if you use the segment from the first parallel line, can't you use tangent of 90 degrees to find that segment? With the 40?
Okay, what's the tangent of 90 degrees?
Oh, it's cool.
That didn't help us any, right? When we're using our sines and cosines, we're using the acute angles of the right triangle and never the right angle. Because that right angle is going to have sines and cosines that spit out zeros. Yes, ma'am.
I think we have the right deal with the, like.
You want to go back to here?
Yeah.
Okay,
The 90 plus 64, and then that whole line makes 180 degrees.
this whole line here. So you want to know what this angle is?
Yeah, and then like the one.
Okay, I'm game. Let's keep going. Okay, 54 plus 90 is 144. And so you're looking at this angle right here.
The one next to it is 54, and then 54 plus.
So this angle is 36. Okay,
That little corner right there, I mean, right to the left of it,
this one
or to the right of it, I mean.
to the right of it.
Wasn't that
To the right of, give me a noun for the it.
like the alternating shorter angle?
Of which one?
Like the right angle right there.
The right angle right here.
Well, the one inside the right triangle.
That one.
One over.
To the right.
There's a right angle, there's a right angle, there's a right angle. I got that. So that just tells me this is 36 degrees. We could have done vertical angles, right? To get to that 36 degrees. Okay. And so I have what? What am I looking with that? That's 20 feet here. A 36 degree angle there. That was given. Oh, I'm sorry, I put it in the wrong spot. The hypotenuse is 20. Okay. And so keep going. You're rocking. Remember what we're trying to do.
The line adjacent to the 36 degrees, you can put an X on that and then use the formula to get 36 degrees.
So you want to find this length right here?
The one on the right triangle.
The-
All the way over to the left.
This right triangle.
Yes, and then put an X next to the 36, like the line adjacent to the 36.
Okay, why do you want that one?
Oh, I mean, it really doesn't matter which one.
Okay, so that you can get this whole length here?
Yes.
So what is it that we're trying to find first? Are we trying to find the bearing or are we trying to find this distance? Let's get our game plan together.
No, we want the other one so we can find the right triangle the other side, yeah.
You are looking, I don't know what you're trying to find. Answer my question. Are we working on distance or are we working on the bearing? Which one are you thinking on? You're working on the distance. Okay, I was working on the bearing.
If we can find the length of both sides of the left, right triangle, we can have the bottom leg to the 40.
Right?
And then you have the top or the vertical leg.
Yeah, we can get this piece and we can get this piece with what we know about that angle. And then that leg will give us our distance. So we're this close to getting that distance between the time at noon and the time at 3.
So the right triangle all the way over to the left, the one with the hypotenuse.
This one?
and X, yes, ma'am.
Let's use that and find the parts.
Yes, if you put the X on the opposite, then you can use sine to get
Well, I'm going to put a Y over here. I'm going to find both X and Y because we need X to get the big leg. We need Y. And once we have X and Y, we've got the distance between the two ships. So let's go ahead and work on that.
Wouldn't it be easier since we created that small right triangle, wouldn't it be easier to take, since all the triangle would equal 180, take the 90 degrees plus the 54 degrees, and then take the 36, which is, it's across that line, if you treat it like
Yeah.
a transversal, that top corner should be 36. So you do
Correct.
54 plus 90 plus 36 gives you the opposite angle.
But why, do we need that? I mean, with what we got now, we can go ahead and answer the first part of the question.
But what, I'm just asking, wouldn't that be like an easier way to go about this?
There's going to be a gazillion ways to go about this. So I'm going with the way that the flow was taking me.
Okay. that was just
Okay, so I don't want to
curious.
change direction right now. I'm going with what my feedback was initially. Okay, so there's a whole bunch of ways. If this wasn't the way that some of you thought of it. If this was the way that I was getting your answers, let's continue because we're this close. You see that little shaded triangle? We can find both X and Y. So let's get X. X is adjacent to the 36-degree angle, and 20 is the hypotenuse.
We're gonna use cosine.
So I'm going to use a cosine. So the cosine of 36 degrees is adjacent over hypotenuse.
And then that gives you 20 times the cosine of 36.
Okay, now let's find Y. Y is opposite that.
Sine.
So the sine of 36 degrees is Y over 20. So Y is equal to 20 sine 36. And so this distance here can be found if we take our X and we add it to our 40. Okay, so we have that C squared is equal to X plus 40 squared plus Y squared. So C is the square root of all that. Everybody with me? And so that's what I did. And now I've got numbers for X and Y, so we plug them in. 20 cosine of 36 degrees plus 40 squared is the X plus 40 squared. And then the Y squared is 20 sine of 36 squared. And that whole thing is the distance between the two ships. So let me get that. So let's see. 20 times the cosine of 36 plus 40 all squared plus 20 sine of 36 all squared. Add them together and then take the square root. And let me see what kind of distance I want. I want a whole number distance. So C is going to be 57 nautical miles.
So you want above that is our test answer, correct?
I'm sorry?
The one above that is our test answer, correct?
The one above that. Here's your test answer, yes. Okay, are you good with the distance between the two ships? Okay, so the next question is to find this bearing right here. So let's see how we're going to do that. We've got this 36-degree angle. We've got a 54-degree angle. We've got this missing triangle down here. What I'm trying to get for this bearing, let's see, if I use these two things here, that angle here would correspond to this angle here. These two angles are congruent. I don't know if I want to work that hard. Is there an easier way?
You've already got the 36 and the 90 degree on that triangle.
Correct, so we can get this one. So that would be what, 54? And then the angle vertical to that would be 54. Okay, so that, I need more. I need another wee bit there. Where else can we go? Where else can we go?
That 36 right there.
That 36 right there.
The 36 and the
That-
54,
That 36 and the 54, where's this 36 gonna go?
makes it 54 on the left side.
That's not a right angle here. That's not necessarily right angles because I got that by extending this line here. But that's not a right angle. If I could figure that out, I'd be happy. Let's see.
You just take the tan inverse of both sides.
To get which angle?
whatever you want.
Okay, so if I've got all these sides here in this triangle. So you're gonna find this angle here?
Yeah.
And then we can take the complement of it? Let's do it. We've got this big triangle here. And we've got, oh, I need to get a number out of this. X was 20 cosine of 36 degrees. Y was 20 sine of 36 degrees. And we're trying to find this angle here. So let's put a theta there. And so I know that the tangent of that angle theta is the opposite over the adjacent. But those 20s cancel. Sine of 36 divided by cosine of 36 is the tangent of 36. So that angle is 36 degrees. So if this angle is 36 degrees, what's the measure of this angle? 54 degrees. So let's write that as a bearing. A bearing of north, 54 degrees west. Yes, sir.
We're looking at the big triangle on the right?
We're looking at the big triangle, period.
Yeah.
Oh, I lost the x plus 40. Fudge, x plus 40. So I can't do that canceling. That's going to be plus 40. So let's keep working. Good eye on that one. I can't cancel the 20s. Let's keep that there. Let's go ahead and get that number. And then I want the inverse tangent of that number. Can we get out of here? Another 10 minutes. That threw me off. Okay, so I'm going to get this number. And let's see, I've got 20 sine of 36, and I'm going to divide that by 20 cosine of 36 plus the 40, plus I said. And then I want the inverse tangent of this number. So here's this number. And so theta is the inverse tangent of that. So I want the inverse tangent of 0.209294. And I'm going to get that angle up there is 11.8. Let's go ahead and round that to 12. Doesn't look like a 12-degree angle, does it? So I hope I didn't punch any buttons wrong. That does stink, doesn't it? So I didn't punch in the right numbers. I don't know how big of a deal that's going to make, but that's the idea. So we went, whatever number that is, we'll say 12 degrees for now. So we went, yeah, 12 degrees will do us. That's not gonna make it. So from that north line, the bearing is north 12 degrees west.
Where the 36 is.
No. Oh, yes, yes, yes. That's the 12 degrees. So what's left of 90 minus 12? 78? Good gosh. Good gosh. That was a long ass problem. You guys have some fun in store for you. All right. I thought you said we had 10 minutes. Where are you going? Time for a beverage. It's 5 o'clock somewhere. All right, let me tell you what's happening next. Today is September 9th. What happens 1 week from today? We're going to have our first test 1 week from today. Let's put our test all the way through section 2.5. Yes. So exam 1 is Thursday, September 16th. It will be an in-class test. I don't know how I'm going to deal with folks that aren't in class. So hopefully that you guys at home can show up in class. I'll need you in class here. Sections 1.1 through 2.5. So that section in there where you use your calculators just to help you do stuff like this. But on the test, I'd rather you not use a calculator, just stop, because I don't want to look at numbers. Yes, I'm going to post on Blackboard a review sheet on Blackboard. I'm going to do it today. If I have one. If I don't have one, then I'm up a creek. And on Tuesday, we will review in class. So if you have time over the weekend to go through that review sheet, I'll take your questions over it. And we'll get all caught up on our web work through 2.5. Yes? Test is during class time. So you squeeze your little bodies together in here. And I'll probably make several versions of it so that your eyesight isn't part of the test. Not a practice test, but I'll have a review sheet. So I'll get everything organized for you. You do the memorizing part, go through the review sheet over the weekend. Try to get your web work done as far as you can so that on Tuesday we can answer web work questions and review for exam questions. Everything's good? Now you can go. So if any of you at home are going to have trouble coming to class on Thursday for the test, I'm going to need to know in advance so that I can make arrangements for giving you your test. If there are no questions, I'm going to go ahead and stop sharing and stop the Zoom.
I need to rest tomorrow. Have a good day.